Hi, welcome on I think last part of the video tutorials on BasicCam. In this part I will show how to use the settings to generate the G-code, the programs for 3-axis mill. Okay, let's start with generating some new project. Let's for example say our bed is 1000 by the 1000. Okay, and we want to generate for 3-axis mill. Okay, we can see that's the size of the bed, 1000 by the 1000. It's okay. Let's load some image into our background. Okay, and yeah, that's it. Looking pretty well. Some kind of the mirror or a frame, and it's a poor quality because the size of the image is at 236 pixels by the 303 pixels, and yes, it's poor. We have a JPEG compression all over the places. The edges are just a bit blurred, but let's see what our algorithm can do with detecting the edges. Okay, engrave. Engrave will simply move the tooltip in a material only on the edges, as the wire plotter doing or a laser plasma. It's just cutting the details or cutting the edges of the details. Yeah. All right, we have an option for a spindle max speed. If our controller supports that parameter, we can just set a maximum spindle speed. If we have, of course, manual, we need to do that manually. There is a PWM for a spindle. I mean the speed. If the speed is, for example, 2,500, we can just go, for example, 50% of that. But that's when our controller support that. Of course, there is a edge detection level. That's the same as the detection level in these parameters in a wire ADM or matrix, just to generate the edges of the picture. There is a parameter lift to travel. That means how high the tooltip will be lifted over the material when the machine moving are traveling from one to another point. That's a material surface level. That means if we put some kind of the block, for example, plywood material, and that plywood is, for example, 10 millimeter thick, yeah, we're just offsetting the tooltip to the top of the material to just touch the top of the material, and then we're offsetting the machine to be a 0, 0, and that's where we will start, and that parameter is how deep the tooltip will go into a material. That means we will cut with some engraving tip with a 1.5 millimeter deep. Okay, that's a speed to travel in air. That's a speed to travel in a material. Okay, simple as that. We're clicking background to matrix, and now we click compute. Of course, this time computing are taking a really slow because there is a plenty of points. We can just zoom it in and see how much points is on the lines. I hope the YouTube showing that, but each of these details contain something kind of hundreds of the points, and some of them are hundreds of thousands. And when the algorithm calculating connections, it's looking all over the points, where is the closest points, and that's why it's going so slow sometimes. But it will speed up gradually when it removes all the points, because when it calculates the full line, it detects the full loop. It just removing that points from the matrix, do not calculate again them. That means we need to just wait. Of course, in the same moment when it's calculating the edges, it's trying to smooth them up if there is any points which are just out of the plane. That means they're not in some kind of the straight or even a curved line, but they just jump out a little bit on the left or right from the line. They are just eliminated. Only the straight lines are taken into consideration. I mean, this algorithm should just end up with a bit better quality, much smoother lines than just edge detection. Of course, another thing which is slowing it down a little bit is I'm running this program at this moment in a debug mode. That means not a full release compile, and that's making it working a bit slower, because if something go wrong, I can just start debugging the program immediately. That's why it's just going a bit slower than it should. Normal compilation, which is available for you, it's of course a release compilation. It should go a bit faster. I think when it finished this long loop around the perimeter, it should speed up. Okay, I think it's more of the half of the points are eliminated already. Okay, and it's done. Considering the image quality and how poor some edges are, I think the algorithm did pretty well. Okay, we have that. We can just go simple to our CAM. Of course, we use fast mode, and we can just simple calculate tip path. It's done almost instantly because we already calculated all the lines and the direction of them, calculating that edge detection. We didn't need to recalculate all the connections, and that's why it's going so fast. Now we can just simply save the G-code as mirror. Okay, I replaced that because I just did that before. Or we can just send it to the controller, or we can just simulate it. Of course, that speed of the generation and the size of the material is taken into consideration in the simulation. That's a standard speed, as a speed up by some parameter like a 45 times. Okay, and let's see the image. I don't know if it will show it correctly. But the G-code for that. Yes, there is a G-code here. We can load it on a SD card. We can load it to kind of the program or whatever controller you're using. It should be able to just regenerate or just work on that G-code. Okay, all right. So let's go to something more complicated with a milling. We will generate maybe something smaller, like a 500 mils by the 500 mils. Okay, and we will select Z image mapping, and that Z image mapping is again, something which most of the CNC machines doing. We'll use a Z image buffer. Okay, and now we have the same settings and in laser. Diagonal, it means simple, the line will be at 45 degrees for sparing the bearings on axes. That means both axes will be used in the same way. That's a cross path. It will generate a second path of the tool. First path will be in one direction, second path will be in another direction. That's a parameter. Minimum depth and the maximum is the same. Material surface top is a 0, 0. We can of course change it to for example 5, and then all this parameter will be offset according to that parameter. There is a lift to travel, how high we need to lift the tool if we need to move to a next line or something like that. There is a minimum depth. That means if material is, for example, 10 millimeters or maybe 20 millimeters deep, then the minimum of the engraving, where is the white top here, would be just 0.5 millimeter, and the maximum, where is the blank, will be a 10 millimeter. And scan resolution is how thin the lines will be close each other. That means that's 0.1 millimeter. That means the tool one line to another line will be just 10 millimeters off to another. That means if we go much thinner to that, then the detail will look much better, but of course time of the machining and the file which we will generate will be massive. Let's see how the 0.3 millimeter will do. And we have of course a speed of travel in air and the speed of travel in the material. Let's try to calculate. Let's see the settings here, maybe not that big. Let's try something smaller, 400 millimeters by the 400 millimeters with 0.3 millimeter toolpath. Okay, this calculation could took some time. Okay, anyway, it's done. Only one thing, I have the edge. I can switch off the frame and regenerate it. Okay, and we see the image behind is generated from the lines. We can just click on info. We have a 315,000 lines. Of course, when we just go in a cross path and just change the resolution to a much higher. Now it's taking a time. Okay, we done the generation. We can check on the project there is 1,043,051 lines. That's a lot. Of course, I'm displaying only a fraction of them at this moment to just not slow down the program too much, and that amount of data is taking a reasonable amount of the memory as well. I mean, when we click a CAM module, we can save the G code, and for example I will save it here. I'll replace the mask, and we can of course send it to USB, but when we click USB, this process could take some time, and there is a little thing at this moment. I'm displaying in this preview window only a first 100,000 lines. I mean, if the project have 1 million lines, I'm not displaying all of them because of the memory requirements, and sometimes program can misbehave, throw some errors and stop working. I mean, just to be safe, I showing only the preview of the first lines, not the full code. And when you click send all, of course I'm sending all of them, not only this previous one, because that's just a preview, and everything should work well. But at this moment I will be working to re-implement that text edit to show pages, to be able to display all of the text. And the next thing which I will be trying to re-implement is preview, because at this moment the program just showing us 2D images. I mean, it's designed to just work on a 2D, but this G-code for the mill, free access mill, could be displayed as a three-dimensional picture, and I will be trying to re-implement to just generate polygons and then show that in a 3D. Then you will be able to see preview how the details should look like after machining. Okay, that's it. Thank you very much. Have a nice day.